Welcome. Today we'll learn few terminologies of NLP or natural language processing. In the world of Gen AI where language processing is key, so understanding concept of NLP is also very important. We'll cover very basics of NLP through this video. Surprisingly, technology are nowadays very smart to perform actions from any language, be it Alexa, Siri, or ChatGPT, etc. So fundamentally, computers are performing very core concepts of NLP. Those are POS, BOW, TF-IDF, chunking, embedding. So let's learn those terminology. I will create another video to understand those from Python or NLTK. Welcome to the fundamental of NLP. Let's understand few more process of language processing like POS, NER, chunking, basket of words, TF, IDF, and then embedding. Let's start with POS. POS is part of speech, which tells us the grammatical information of words of the sentences by assigning specific tokens. So for an example of POS or parts of speech, suppose the original speech or sentence is the blue dress fit her perfectly. So what it does, it first tokenized it to word and then POS, with the help of POS, thou will convert into a specific grammar. Suppose blue will convert to noun and then thou will convert to determiner and then adjective, adverb, verb, personal pronouns, etc. So with the help of POS, we can easily understand the grammatical context of that particular sentence. Whereas NER is the process of recognizing name entity such as person name, location name, organization name, designation or person, so those things. For an example, NER or name entity relation, here Bob works in XYZ company. This is the original sentence. With the help of NER, NLP will understand Bob is a person name and XY is the organization name. And then chunking will use lots of time in our RAG area or RAG context. Chunking is nothing but it actually split entire document or entire sentence into small pieces based on the chunk size. So here for a very high level perspective, if the sentence is like that, so chunking will split that particular document. But don't worry, we will cover lots of things in chunking through Python code. So let's move to the next one. So bag of words and TF-IDF. Moving on to bag of words or TF-IDF. These are the technique used to represent text data into numerical format, which is very crucial for the kind of machine learning including NLP. What is bag of words? Bag of words is one of the simplest way to do this. It creates vocabulary from the entire dataset and then represent each document as a vector or word counts. However, it does not consider importance of words of their context. Let's see for an example. Suppose the original sentence is the cat sat on the mat. This is the sentence 1. The cat lay on the rug. This is sentence 2. With the help of BOW, you can see the vocabulary. First, check the vocabulary of those sentences. The cat sat. It first split those one, right? And then it will put the numbers on the occurrence of those counts of those particular vocabulary. The is 2 times over here, so 2. Then cat only 1 time, so cat 1. So like that way, this is sentence 1 vector, and in case of here, sentence 2 vector. You can see rag is not present in sentence 1, that's why 0. And rag is present in the sentence 2, that's why 1. So this is a numeric representation of the entire 2 sentences, which is meaningful because it is required in case of some classification, document classification. Okay. The other advanced technique is TF-IDF, term frequency and inverse document frequency. In this case, what it does, these are the 2 sentences. First sentence is at the same sentences and it also converts into the vocabulary. But in case of TF-IDF, not only counts the frequency of words, but also adjusts these counts based on how common or rare a word is across all the documents. This way it assigns more weights to informative words and less to common one like the and. Let's see. In case of here, you can see the is only 0.4. Okay. And in case of the other side, the BOW, it was 2. But do you think like the is meaningful in case of NLP to predict any word? I don't think, right? That's why TF-IDF is more advanced. What it does, it actually first see the like term of the like particular frequency, the cat, sat. It actually identifies that particular frequency, and then it identifies that particular frequency in the document itself, entire document, not in the sentence. And then inverse document frequency means there might be a chances like this kind of stop word, the, on, these are the words which will come lots, right? So the document frequency will come lot. So it inverts that particular, if it is coming more, that means those are the like not required from the context perspective. So there is the formula TF-IDF, TF into IDF, and IDF is nothing but actually log of n df plus 1. Okay, so you can look into the formula, you can Google it and understand the formula from the REG perspective to the fundamental of NLP perspective. These are the two concepts are very important to understand. Okay, so I think you have understood bag of words and TF-IDF. Let's move to the embeddings. Let's talk about embeddings, a more advanced technique that represents words in dense vector space, capturing their meaning and relationship to other words. Unlike BOW or TF-IDF, which treats words on sentence independently, common algo used for embeddings are word-to-vec or GLOV, which identifies semantic similarities between words and sentences. For example, the embeddings of king and queen would be closer to each other in the vector space than king and apple, reflecting their related meaning. Similarly, man, woman will be closer. And then country, capital, vector space, you can see India, Delhi are closer in vector space. Sri Lanka, Colombo are very closer to vector space. So whenever any information or any sentence is coming like king or royalty, then it immediately goes to king, and then it identifies queen, but it will not capture apple, right? So these are the entire vector space, and through embedding we can achieve this particular vector space. This is very, very important to identify or retrieve or generate the information from the entire document and give the proper information to user chatbot.
Let's see tokenization. Tokenization is the process of breaking down text into smaller, more manageable units called tokens. These tokens could be words or could be sentences, even subwords, depending upon the granularity needed. Suppose for an example, original paragraph has 2 sentences. Natural language processing is important for RAG. Learning of RAG is important concept of AI. So for tokenization, word tokenization, this will divide it into multiple tokens. This is the word token. For the second sentence tokenization, this will again classify it into 2 different sentences, right? So this is the concept of tokenization, breaking down a large document or large paragraph into small pieces. This is important for the contextual and the finding the similarities of different tokens. So in this case, whenever natural language processing, these tokens will have put into the vector, put into the embedding, and then LLM will find our transformer model will do the similarity search. So token is a very fundamental and basic concept which is the input to the LLM. Next, we have stemming and lemmatization. Both of these techniques involve reducing words into their bases or root form, but they do so in slightly different ways. Stemming involves chopping of words, end of the words, to produce the base form. So suppose the original word is running, better, carry. So I'm taking 2 examples like running and carry. So in stemming, what it will do, it will strip or it will reduce it to run. It will just cut the end of that particular word. And then for carrying, it will come to car. So in case of stemming, you can see it sometimes misleading the original word meaning. So get rid of this. So lemmatization has introduced. On the other hand, lemmatization uses linguistic rules to reduce word to the dictionary form or lemma. For example, running becomes run in lemmatization, and then caring become care. Better maybe convert to good in the lemmatization. By reducing words to their base form, we increase the likelihood of matching queries with relevant documents, even when the exact words forms differ. For instance, a query for running shoes could effectively retrieve documents about run or runner, thanks of stemming or lemmatization. So this is also very much important from the NLP perspective. So tokenization changes, it actually split the text into multiple units, that is called tokens, either word tokenization or sentence tokenization. And in case of stemming, it chopping of the end of the words and actually create a meaningful word from that original word. And in case of lemmatization, it actually identify the dictionary from the word or lemma word. So these are the very important concept of NLP.